Hi, I'm Zhao from Linna and Kyoto University. I'm happy to be here to present you our paper, Multi-Reference Training for Dialogue Response Generation. To figure out why multi-reference training matters, first we want to look at the training objective of open domain dialogue systems. Current open domain dialogue systems mostly derive from this model. The sequence-to-sequence model used for neural machine translation, but used by Venus in his ICML 2015 paper for dialogue response generation. Therefore, current dialogue systems use a training paradigm borrowed from neural machine translation, where for a neural network, which is our dialogue system, we will input a dialogue context and try to predict the response output. And with a bunch of context and response pairs, we can train our neural network to chat like human. But is this the right training paradigm for training dialogue systems? So dialogue is open-ended generation task, while translation is more like a closed-ended generation task. Because given the same input, we can have different translations, but all of these translations will be very similar in both the lexical level and the semantic level. However, in dialogues, we can generate diverse responses, which are diverse not only in the lexical level, but also on the semantic level. So the training paradigm of machine translation is not suitable for dialogue systems. In dialogue systems, instead, we want to learn the probability distribution of y given x, where x is the input context and y is all the possible responses. And we want to know the probability of all the responses given the same context. The ideal training objective to train a dialogue system is to minimize the distance between the real data probability distribution P of y given x and the model's probability distribution P theta of y given x, where theta is the model's parameters. And this distance can be measured by the KL divergence. And the KL divergence between the P distribution and the P theta distribution can be written in such a way. And we can notice in this term, the denominator P of yi given x is not related to our model parameter theta. So we can ignore this term. And instead, we have to minimize the loss function written in such a way. So this is a term which is the summation over all the possible responses. However, this loss function is not computable because we do not know all the possible responses. And of course, we do not know the probabilities of all the responses. In order to build a computable loss function, we have to replace the real data distribution with the training data distribution. So with our training data D and its probability distribution PD of y given x, we get a new loss function where the summation over all the possible responses becomes the probability of the given response. In most data, we only have one response given each context. So the probability distribution PD becomes a one-hot vector. And we can derive such a term that is the negative likelihood. So the negative likelihood is the empirical training objective in most of current dialogue systems. So we can see there is a gap between the ideal objective and the empirical objective. In the ideal objective, which is the probability distribution in real data, each input context has many responses. So we say the data is multi-referenced. However, in the empirical objective, which is the probability distribution of training data, each context has only one response. So we say the data is single referenced. And how can we fill in this gap? To address this problem, we have our first proposal to use multi-reference training. In the ideal objective, the probability distribution is more like a dense vector, where many values are non-zero. However, in the empirical objective, which is a single reference data, the probability distribution is a one-hot vector. So how about build something in between? Instead of have only one reference, we can have multiple references. So, for example, say we have 5 reference data, then in the probability distribution, there will be 5 values that are not zeros. And we can use this new probability distribution to train our model. But how can we get such a probability distribution? We can achieve this by generating pseudo references from a teacher model. And here we use the fine-tuned GPT-2 as our teacher model, and we generate 100 responses for each context via nuclear sampling. And in order to train our dialogue system with a new objective, we can simply replace the original training data with the multi-reference data, which are generated by the GPT-2. To validate our proposal, we did experiments on the daily dialogue corpus. We used the hierarchical recurrent encoder-decoder, the HRED, as our baseline model. And we did evaluations on both automated metrics and also human evaluation. We used Bluetooth score and embedding similarities as our automated metrics. And in our human evaluation experiments, we asked crowdsourcing workers to rate the responses regarding whether they make sense or not, and whether they are specific or not. And also, we reported the average score of these two metrics, which is SSA. This table shows the results of the automated evaluation. We trained the HRED baseline model in different settings of training data. Here, 1GT stands for 1 gram truth, which is original training data. And we also trained HRED with different numbers of generated responses from 1 to 100. By looking at the numbers, we can see that by replacing the original data with generated response and more generated responses, there is a significant improvement in all the metrics. And in the human evaluation, by replacing the training data from original 1GT data to 100 generated responses, we can see a significant improvement. Therefore, we conclude that multi-reference training can improve the quality of generated responses. Another finding is that when we increase the number of generated responses from 20 to 100, there is actually a slight degradation of performance. So we suspect that HRED might not be very good at learning such one-to-many relations. So how can we address this problem? In our second proposal, we proposed a new model that might be better at learning such one-to-many relations between context and different responses. Our first baseline model, the HRED, is a deterministic model, which will encode the input as a fixed vector. And we have to generate different responses from this fixed vector, which is very challenging. Here we use another baseline model, the variational HRED, which is a stochastic model. So instead of encoding the input as a fixed vector, the VHRED encodes the input as a Gaussian variable z, and we can sample different values from the Gaussian variable z to generate different responses. However, in the following experiments, we can see that VHRED is still very poor, and we suspect that encoding the input as only one Gaussian variable is not enough. Therefore, we proposed a new stochastic model of VHRED, but with linear Gaussian model prior. In this model, we input the context and encode the input as multiple Gaussian variables. Then we use these Gaussian variables linear combination as the encoding of the input. In the following experiments, we can see the new model performs much better than both of the baselines. These slides show the results for both automated evaluation and human evaluation. We can see that the new model, the VHRED with linear Gaussian model prior, performs much better than the two baselines, HRED and the VHRED, in both blue scores, embedding-based similarities, and human scores. We can also notice that when we increase the number of generated responses from 20 to 100 in our training data, we can still see a significant improvement in all of metrics. So we conclude that the new model, the VHRED with linear Gaussian model prior, is also good at learning from multiple references. Of course, we compared our new model to models that are designed for learning one-to-many relations from prior works. Here we compared with 3 prior works, and still the VHRD with linear Gaussian model prior performs the best. In conclusion, to address the problem of multi-reference training for open domain dialogue systems, we had 2 proposals. The first is to build multi-reference data, and we generate these new references from a fine-tuned medium-sized GPT-2, and the generated data are all open sourced. And our second proposal is to build models that are better at learning one-to-many relations. Here we propose to use VHRED, but with linear Gaussian model prior. In both automated and human evaluation experiments, the results show that both of these proposals can help us build dialogue systems that generate better responses. Thank you for listening, and check our GitHub for the code and the data.